Assalamu alaikum. Myself Mariam Ali. Today I am going to explain the Verilog operators. So the main purpose of this video is about the implementation of these operators, and today I am going to explain their Verilog codes and how to implement these operators code on the Quartus-15 and get their RTL viewer and their waveforms. So before going to these operators or explaining these operators, there are some basic things about these operators and their codes. So first of all, these are some things 1, 0, X and Z as shown here. So these come into the input, or we can say output, like 1. 1 represents the true one, 0 represents false, and this X, what is X here? So sometimes as some values are not given, or we can say that these are the empty areas, so we can say them unknown or don't care. And the last one is Z. This Z represents the high impedance of any input or any output. Next, so what is this? Size, base and value. This is just a formula that I wrote, but the basic thing of this formula is like that. If I want to write a binary input value of 4-bit, so I am going to write 4, B for binary, and 1011. So this represents the size of this value, like 1011, its size, B for binary, and this is the value that the binary represent. Or else if I want a hex number, this is how I wrote. This is just representing that I have a value that is hexadecimal and it has some 4-bit value. So I am going to write like here X. This X represents that these whole 4-bit X are unknown. So like that, here the things are represented, the inputs are represented here, so we have to put it like that. The next thing is input, output. In the previous functions we just wrote like input X as output as simple number, but if like that, here a function for example this is X, so this is its most bit and this is the most bit here, so this contains the 4. If I'm gonna write in it code, I'm gonna write input 1, 3 and 0 like that. As here 1011, here the 1 is, this 1 is the third, 2, 1 and 0 bit like that. So this is how this basic thing works for the Verilog codes. So let's get into its operators. So first of all, this is the arithmetic operator. So these are the key symbols of this arithmetic operator. Arithmetic operator is just simple things that we done in our mathematics, like addition, multiply, subtract and the module things. I implemented on the Quartus-15 and I run it already because it took a lot of time. So just I'm gonna show you this implement like that. Module, the name of the code here, or the input output that we are gonna define in our code here. I'm gonna write it in the bracket here. So this is what I'm explaining before, like its bit. Now these A and B are the 4-bit numbers, so 0 to 3 are defined here as bit. Similarly, at the output, these C, D, E and F, G are the 8-bit number. So these are defined as a 0 to 7. Furthermore, these are assigned values, like I want them. These are the functions that we are going to perform here. Now let's get its RTL viewer here. Just click it right, locate node, locating the RTL viewer. Yes. So this is the basic RTL viewer I got here, like here addition, subtraction, other things like happening here. So for the waveform of this software, just click here file, the university program VWF. Okay. At the right here, insert notepad, node finder, list, this, okay, and okay. So how now I'm gonna define these values here. Like A have value of 12 here, B has a value of 3. So how to define here now? Okay. To define these input on the waveform here, this is the most simple method. Just click right on this, radix, and these are the values. Like if I want the input in the binary, octal, hexadecimal, signed or unsigned. This signed is the simple decimal are simple, but for the signed these are negative value, and for the unsigned these are the positive. So for now I have chosen unsigned decimal. So let me just click all these and let them unsigned decimal here. Let's check this multiply thing as the binary one. Okay. So now how to give them input like 12 and 3. So this is the arbitrary value for any number. Just click it, and if I want set as binary anyone, I set it already as an unsigned decimal. So like that. Now its value is 12. So signed here 12. Similarly, give the value to the V like we give the A, and just run this simulation. Save it, and now wait for the simulation flow progress. This is now happening here. So this is the code main. Now check it if this is okay or not. Like here, no. They see 0101001 like code here. Now when the output is done, things are done. If still you want them in the binary or hex or any other, just click them, click right, or they convert into the binary number. This is how simple these things are done. Further, let me explain the other one. Logical operators. So now next thing is the logical operators. So what are the logical operators? Logical operators are like they are going to evaluate what is true, what is false, and what is unknown. When a thing is true or non-zero, it's going to represent as 1. When a thing is 0 or when an operand is 0, then it's going to represent it false. And in other case, when a function is or when the operand is unknown or it is at a high impedance, then it evaluate as false, or it will gonna evaluate as unknown. So there is a example or the exercise of this code that what do you evaluate to 67 or 0 and 1? logical AND 1, 1 logical OR 2, and this thing. So how is this gonna work here? I'm just put these values here, and this is how this come. If for the E is equal to not logical not A, so the logical not of A is, let's check this. The logical not of A is, this output here is 0, as it is the logical, it is non-zero, so its value is 1, but it contains not, so it's represent 0, that is false. Furthermore, these logical not here, logical and B and C. For the logical not B and C, B is 0, C is 1. So 0 and 1, it represents 1 here. Similarly, for the C and D are 1 and 2. Both are the non-zero, so it's gonna represent it as 1. For the last one that we have to evaluate, what value of gamma is displayed if the following module is run? So if the following module, what is the following module? This is the following module, like assign alpha 2 is equal to naught of beta, gamma is equal to alpha 2 naught of logical or of beta. So this alpha 2 is equal to logical not beta is going to implement here, and it's going to get 1 on both. So how it get 1 on both? Like for the beta 1, logical not of beta. The logical not of beta is the input. We assign its input beta as 0. So when the input is 0, so its not is 1. So its not is 1. That's why here the alpha is 1, and after when the gamma is equal to alpha 2 logical or beta, then it's 1 1 gonna 1. So this is how this logical NOT code works. Let's get on to the next operator, relational operator. Relational operators are like the simple mathematics things like we perform here, less than, more than, equal to, or more than equal to, like that. So these operators are gonna define like true or false as the logical operator give us. This is the code here, like A is less than B, A is greater than B, A is less than or equal to C, greater than or equal to C, D is greater or equal to A. So let's check it. A and B. 2 is less than B, 5. So it's true, it evaluates 1. 2 is greater than 5, its evaluate 0 as it is wrong. Similarly, next thing are equality operator. What are the equality operator? Like equal and not equal are the simple operators that we apply as if 2 is equal to 2 or 2 is not equal to 3. So these things are a simple equality. But furthermore, what these double equal and not double equal are the logical equality and logical non-inequality. Similarly, these double triple equal and not triple equal are the case inequalities. So what is the difference between double equal and not double equal? Not triple equal. So these triple equal are the case case equalities, and these are the high equalities. Like if a thing is like here, if a thing is like 101x equal to 101x, if it contains double equal, then it's going to represent x, as this double equal just modified that it is unknown, it contains unknown bit, so its result is unknown. But if it contains triple equal, then this triple equal case equality is going to define it one, that these are equal. So this is the difference between triple equal and double equal. Next are the bitwise operator. So what are the bitwise operators? These are the negation and OR, XOR and XNOR side. So these operators are gonna operate like bitwise thing. So how these gonna work? Like if a thing is bitwise negation. Now A is 1100, so its negation is 0011. Similarly, E is A not C, A and not C. So its negation is like we are going to start at the left to the zero least bit. So let's start here. 10 bit AND. So for the AND one, it only when the both are 1. So 1 0 0 1 1 1 and other 0 0 and 1 1. So the AND bitwise is only 1 when both are 1. Similarly goes for the other gates. Next is the reduction operator. So what are the reduction operators? Reduction operators are basically not of are the AND, NAND or XNOR. So what is the difference between this reduction operator and the bitwise operator? The bitwise operator are working like 1 bit and the reduction operator are now working like for the 2 leftmost bit. So this is the difference, otherwise the functions are same for both. Shift operator. Shift operator is basically a vector. The causing as from if we want the shift to the left, if we shift the number to the left, then we are adding the 0 to the right. If we are taking left shift, we are adding 0 to the right. So like that. For example, let me do here. If a thing is 1011, if we are moving the shift to the right as 1, so 011 is moving to the left, so now 0 is added to the right. Similarly, if we are adding to it, if we are shifting it to the right, so it is like that 101. This 1 is removed. So now adding to the right left as we move it to the right. So now this is the concentration. Concentration is the most simple one as it considered as the size net, register, bit select, part select and constant thing. So here like input B10. Now its bit is from 0 to 1, so contain 2 bit. C is the 0 to 5 contain 6 bit. And for the D, E 0 to 3 like 4 bit. So for the here as we design here, D is equal to curly bracket A and B. So these curly brackets are formed for the concatenation. So it's combine the value like that. If a 3-bit number 101. So the thing is 10 and other number is 11. So when we are define it in the curly bracket A comma B curly bracket, then its number become 1011 like that. This is how these concentration work. Next is the replication. So what is replication? Replication is the increase of a bit. Like if a bit A is equal to 1, then its replication, if we did it 5A, this replication gave it 5 into A is 1 1 1 1 1 5 1. So this is how this replication work. So today now these type of operator work, and hope so you understand this. Allah Hafiz and thank you.